The theme for our teaching presentation is cloning of transgenic animals. First of all, some basic definitions. Clones can be defined as organisms which are genetically identical to each other. They can occur in nature, i.e. identical twins, or asexual reproduction in simple and unicellular organisms. This project will focus on artificially created clones. Transgenesis is the introduction of an exogenous gene into an organism to alter its phenotype. For example, creating fluorescent fish or mice. The theme for our teaching presentation is cloning and transgenic animals. First of all, some basic definitions. Clones can be defined as organisms which are genetically identical to each other. They can occur in nature, i.e. identical twins, or asexual reproduction in simple and unicellular organisms. This project will focus on artificially created clones. Transgenesis is the introduction of an exogenous gene into an organism to alter its phenotype. For example, creating fluorescent fish or mice. To follow this up, I am going to give you some history of these two concepts. What many people may not be aware of is the fact that cloning experiments date back to the 19th century. In 1885, a German biologist, Hans Reich, who had a particular interest in embryology, demonstrated that it is possible to create a clone of a sea urchin, which is shown in the top picture, by merely shaking a single-celled embryo, causing it to split into two identical embryos. It took many years of extensive research until the first transgenic animals were created. Rudolf Janisch, working at MIT, inserted leukemia DNA sequences into mouse genomes in 1974 by means of a retroviral vector. The creation of Dolly the sheep is inarguably the most famous cloning experiment of to date. It took the team of researchers led by Ian Wilmot 277 attempts to finally create her. What made Dolly so special is the fact that she was the first mammal to be cloned by somatic cell transfer. The donor cell that provided the nucleus was an udder cell. Udder is a type of mammary gland found in female cattle and sheep. One of the most recent contributions to the field was the creation of a human stem cell by somatic cell transfer by Shukrad Mutadipov and his team in 2013. The donor cell was a skin cell.
So I'm going to discuss the very basic steps involved in recombinant DNA technology. So first, we want to cut out the desired gene. So we have our DNA strand, and these yellow arrows indicate the location of our desired gene on the strand. So we can use restriction enzymes to cut out our desired gene that we want to insert into our plasmid vector. So we need to cut that as well to make room for the foreign DNA fragment. The second step is to insert our gene fragment into the plasmid vector. And we can do this using DNA ligase enzymes, and that creates a recombinant DNA molecule. So the method of introducing the recombinant DNA can depend on the target cell. For example, bacteria cells will take up plasmid vectors. Viruses can also be used as vectors, as they will insert their recombinant DNA into the target cell, using it as a host. Then a technique used when breeding transgenic animals is to micropipette the DNA into the pronucleus of a gamete. So that's just a quick overview of the steps involved in recombinant DNA technology.